Let's take a look at this example. This time we have a circuit which contains the current source. But in our case, this is not going to be a big problem. And we're supposed to simply again look what we can do in order to find Z total. Please notice that our circuit contains capacitors and inductors. So the very first thing you're supposed to check what is given if it comes to inductance and capacitance. We have given inductance 15 millihenries and we have given capacitance. So it means that we're supposed to find the inductive reactance or impedance of the inductor, or capacitive reactance, which we can say this is the impedance of the capacitor. So this is the very first thing which you're supposed to do. Please notice that the frequency is not given. That's why we are going to use the omega. Okay, so this is omega. So we're supposed to write that impedance of the inductor is equal omega L, where omega is equal 44,000 pi radians per second times the inductance, which is equal 15 millihenries. Okay, multiply these two values by themselves. You're supposed to get the value of 2.07 kilo ohms and angle of 90 degrees. Okay, so this is the impedance of the inductor. Next, we're supposed to find the impedance of capacitor C1. This C1 is equal 1 over omega C1. So I have 1 divided by omega is equal 44,000 pi radians per second times C1, which is equal 6.2 nanofarads. Again, use the calculator. You're supposed to get the value of 1.16 kilo ohms and angle of negative 90 degrees. Remember, anytime we talk about the impedance of the capacitor, you're supposed to add angle of negative 90 degrees or simply negative J. But as I said before, we are going to use most of the time the polar form. Okay, so next we're supposed to find the impedance of capacitor C2, which is equal 1 over omega C2, which is equal 1 divided by, open parenthesis, 44,000 pi radians per second times 8.6 nanofarads. This is equal 841.19 ohms and angle of negative 90 degrees. Okay, so we found the impedance of capacitor C1, impedance of capacitor C2, and we found the impedance of the inductor. Next, we're supposed to find the total impedance. In order to find total impedance, I'm going to find first impedance for these two components, and please notice that both of them are connected in parallel. That's why I'm going to call these two components together Z1, impedance Z1. These two components, inductor and resistor, are connected in series. I'm going to call this Z2, and these two are again connected in parallel. I'm going to call this Z3. Okay, so we have to combine these two components first, these two and these two. And at the end, we are going to combine all of them together and we are going to get Z total. Okay, so let's talk about Z1. Because resistor R1 and C1 are connected in parallel, I'm going to use the product over sum. because I have two components, okay? So I have Z1 is equal R1 times ZC1 over R1 plus ZC1, where R1 is equal 820 ohms times ZC1 1.16 kilo ohms and angle of negative 90 degrees over, open parenthesis, 820 ohms plus 1.16 kilo ohms and angle of negative 90 degrees. This is equal 669.59 ohms and angle of negative 35.25 degrees. Okay, so this is the impedance of these two components together. Next, I'm going to find Z2. As we said before, Z2 is the combination of inductance, impedance of the inductor and resistance, and they are connected in series. That's why I'm going to simply add them up. Z2 is equal R2 plus ZL, where R2 is equal 1.3 kilo ohms plus ZL, which is equal 2.07 kilo ohms and angle of 90 degrees. Add them up, you're supposed to get the value of 2.44 kilo ohms and angle of 57.87 degrees. Okay, so this is the impedance of these two components connected together. Next, we're supposed to find Z3. Z3 is going to represent the combination of resistor R3 and impedance of capacitor C2. Because they are in parallel and we have just two components, I'm going to use product over sum again. So if Z3 is equal, I have R3 times ZC2 over R3 plus ZC2, where R3 is equal 1.5 kilo ohms times ZC2, which is equal 841.19 ohms and angle of negative 90 degrees over 1.5 kilo ohms plus 841.19 ohms and angle of negative 90 degrees. Use the calculator. You're supposed to get the value of 733.69 ohms and angle of negative 60.71 degrees. Okay, so this is the impedance Z3. Now we can redraw the circuit in order to look this a little bit simpler. So I have current source and I have Z1, I have Z2, and I have Z3. Okay, now we're supposed to find Z total. So please notice that Z2 and Z3 are in series. So right now I'm going to find Z23. Z23 is equal Z2 plus Z3, where Z2 is equal 2.44 kiloohms and angle of 57.87 degrees plus Z3, which is equal 733.69 ohms and angle of negative 60.71 degrees. Okay, at the map you're supposed to get the value 2.18 kiloohms and angle of 40.72 degrees. Okay, so we found Z23. Now you can redraw the circuit, and we have Z1 and Z23. Please notice that these two impedances are in parallel right now. Okay, because I have two impedances, I'm going to use the product over sum in order to find Z total. So if Z total is equal Z1 times Z23 over Z1 plus Z23, which is equal, Z1 we found is 669.59 ohms and angle of negative 35.25 degrees times Z23, which is equal 2.18 kiloohms and angle of 40.72 degrees over 669.59 ohms and angle of negative 35.25 degrees plus, of course, open the parentheses, 2.18 kiloohms and angle of 40.72 degrees, close parenthesis, in the denominator. This is equal 600.51 ohms and angle of negative 19.74 degrees. Okay, so your circuit right now looks like this. So right now we are ready to find the current IR1, voltage VL, and current IC2. In order to find the current IR1, I'm going to find first the voltage across Z total, and after that I'm going to use Ohm's law and divide that voltage by R1. How I'm going to do it? Let me show you. So I'm going to find voltage across Z total. I'm going to use Ohm's law, so this is I source times Z total, which is equal I source. I'm going to express this current in phasor form is 5 milliamps and angle of negative 30 degrees times Z total, which is equal 600.51 ohms and angle of negative 19.74 degrees. Use the calculator. You're supposed to get the value of VZ total is equal 3 volts and angle of negative 49.74 degrees. So this is the voltage which we are going to measure across the impedance Z total. Please notice that Z total is the combination of impedance Z1 and impedance Z23, where impedance Z1 represents capacitor C1 and resistor R1 combined together. So it means that the voltage which I'm going to have across Z total is the same voltage which is going to appear across Z1 and Z23. Let me write this down. VZ total is equivalent to the voltage VZ1 is also equal to VZ23 and is also equal to VC1 and is also equal to VR1. Why? Because we talk about the parallel circuit. Okay, so voltage across each impedance over here is the same. So voltage across each impedance, I mean C1, V across the capacitor C1 and voltage across resistor R1 is the same. So in order to find current IR1, I'm going to use the Ohm's law. IR1 is equal VR1 over R1, where VR1 is equal 3 volts and angle of negative 49.74 degrees over R1, which is equal 820 ohms. This is equal 3.65 milliamps and angle of negative 49.74 degrees. Okay, so this is the current which will go through resistor R1. Next, we're supposed to find voltage across inductor. In order to do so, you're supposed to realize that the current which will go through impedance Z2 is going to be equal to the current which will go through impedance Z3. Okay? So, in order to find this voltage, I mean voltage across the inductor, I'm going to use Ohm's law. Okay, so I'm going to find this by finding the current IZ23. IZ23 is equal voltage Z23 divided by Z23. Okay, we said that the voltage Z23 is equal 3 volts and angle of negative 49.74 degrees over Z23 is equal 2.18 kilo ohms and angle of 40.72 degrees. Calculators are supposed to get the value 1.37 milliamps and angle of negative 90.46 degrees. Okay, so this is the current which will go through this impedance. This is IZ23. So keep in mind that impedance Z23 represents the impedance of these two impedances. So I can say that the current IZ23 is equal to the current which goes through impedance IZ2, and this is also the current which goes through the impedance Z3. Also, please keep in mind that the impedance Z2 represents the inductor and resistor together, okay? So, because they are in series, I can say that this current, which I just found, is equal also to current IL and current which goes through resistor IR2. Okay, so in order to find VL, I'm going to use Ohm's law. VL is equal IL times ZL. Okay, so IL is equal 1.37 milliamps and angle of negative 90.46 degrees times ZL, which is equal 2.07 kilo ohms and angle of 90 degrees. This is equal 2.83 volts and angle of negative 0.46 degrees. Okay, so this is the voltage across the inductor. In order to find the current which goes through C2, I'm going to use current division law. Okay, so I'm going to use this current. Okay, so this is current IZ23, and I'm going to simply use this current as the total current for this part of the circuit only. Okay, so I'm going to write that IC2 is equal IZ23 times the total impedance of these two components, which is Z3, over the impedance of the capacitor, because I'm looking for the current which goes through the capacitor, so ZC2. Okay, so I have IZ23 is equal 1.37 milliamps and angle of negative 90.46 degrees times Z3 is equal 733.69 ohms and angle of negative 60.71 degrees over ZC2, which is equal 841.19 ohms and angle of negative 90 degrees. Plug in these values into the calculator and you're supposed to get IC2 equal 1.19 milliamps and angle of negative 61.17 degrees. Okay, so we found Z total, IR1, VL, and IC2. So we can say that the problem is solved.